Here's a safe harbor statement, and I'm joined here by Nathan Fuzi, who's a senior principal product manager. I am Divit Gupta, senior principal product manager for Oracle Multicloud. So this webinar is going to cover a little bit about Oracle databases, what are the different versions, flavors, and how we can provision Oracle databases on AWS. And we'll talk a little bit about other cloud providers as well, hyperscalers as well. So imagine, what if you could migrate Oracle database workloads to AWS? What if you could unify your data across Oracle and AWS to innovate? What if you could simplify your management and operations? So on Oracle X database uh, service on dedicated infrastructure, or Oracle Autonomous Database on dedicated infrastructure. And when I talk about unify, we can do by generating deeper insights with zero ETL integrations to unify your data across Oracle and AWS for analytics, machine learning, and very recently, which came out, generative AI. And we can simplify with your existing AWS and Oracle database skills, tools, automation, and processes in a multi-cloud environment. So Oracle database at AWS, probably the best of both worlds. Oracle database at AWS provides customers with a unified experience across OCI and AWS, featuring fully integrated support from both companies that simplifies database administration, purchasing, and deployment through reference architectures and landing zones designed for customers' most trusted enterprise application. Customers can also benefit from simplifying and accelerating the migration of their Oracle databases to the cloud, including compatibility with proven migration tools such as Oracle Zero Downtime Migration. Remember, you can use the zero time migration to move the Oracle workloads. Highly resilient and scalable workloads with Oracle RAC. RAC is real application clusters, multiple AWS availability zones, and Amazon S3 for database backups and disaster recovery. A simplified procurement experience via AWS Marketplace. Customers can use their existing AWS commitments and Oracle license benefits, including BOIL, which is bring your own license, and discount programs such as Oracle Support Rewards, OSR, and Oracle Database at AWS. Building new scalable microservices-based applications by combining Amazon EC2 instances, Amazon EKS, and Amazon ECS with Oracle database features like AI vector search to enhance application intelligence and accelerate time to market for new features. Oracle Database at AWS offers Oracle Database 23 AI that supports embedded Oracle AI vector search, providing customers with a simple way to search documents, images, and relational data based on their conceptual content rather than specific words, pixels, or data values. Familiar tools such as AWS Management Console, AWS Command Line Interface, APIs, and monitoring to easily manage their workloads while preparing their data for use with advanced analytics, machine learning, and generative AI services, as well as integrations with AWS services, including AWS Identity and Access Management IAM, AWS CloudFormation, Amazon CloudWatch, Amazon VPC Lattice, and Amazon EventBridge. So we have support for Oracle application. They have support for Oracle applications such as Oracle eBusiness Suite, PeopleSoft, JD Edwards, Enterprise One, Oracle Enterprise Performance Management, and Oracle Retail applications. So let's talk a little bit about autonomous database. There's a lot of buzz about autonomous database on Exadata. So let's talk a little bit about that as well. And also Exadata, which is Exadata is the foundation for premier Oracle database services. Autonomous database provides an easy to use, a fully autonomous database that scales elastically and delivers fast query performance. As a service, Autonomous Database does not require database administration. It's fully automated. With Autonomous Database, you do not need to configure or manage any hardware or install any software. Autonomous Database handles provisioning the database, excuse me, backing up the database, patching and upgrading the database, and growing or shrinking the database. Autonomous Database is a completely elastic service. At any time, you can scale, increase, or decrease either the compute or the storage capacity. When you make resource changes for your autonomous database instance, the resources automatically shrink or grow without requiring downtime or service interruptions. So it's a fully scalable solution and scalable and elastic. Autonomous Database is built upon Oracle Database so that the applications and tools that support Oracle Database and also support Autonomous Database. These tools and applications connect to Autonomous Database using standard SQL net connections. The tools and applications can either be in your data center or in a public cloud. Oracle Analytics Cloud and other cloud application or other cloud services provide support for Oracle autonomous database connections. So autonomous database provides some of these things. Increase some of the features, right? Increase your app development velocity. You can build and deploy quickly on unified platform supporting vector, JSON, graph, and more. You can leverage scalable, cost-effective solutions with flexible cloud, multi-cloud, or on-premises deployment, advanced security, and self-service tools. Fully automated database service, that's what Autonomous is. Supports all modern Oracle data types, workloads, including transaction processing, AI, and analytics, reducing the need for multiple specialty database. Maximizes your data security and availability. With Oracle Autonomous Database Service, you can keep your mission critical applications running by leveraging 99.995% availability. Allows you to bring AI to your data. Use LLMs with built-in AI, vector search, and proprietary data to get more accurate answers. There's no need to duplicate data or to a separate vector database. Also, Autonomous Database includes Oracle Apex, which is a low-code development platform that enables you to build scalable, secure apps with world-class features. It also has Oracle REST Data Services, ORDS. It's a Java Enterprise Edition based data service that makes it easy to develop modern REST interfaces for relational data and JSON document store. Database Actions is a web-based interface that also uses Oracle REST data services to provide development, data tool administration, and monitoring features for autonomous database. It has Oracle Machine Learning, a set of components supporting data scientists, ML engineers, and data analytics, as well as SQL, R, and Python users. So components include SQL, R, and Python APIs, a built-in notebook interface, and no-code interfaces for AutoML, data and model monitoring, and model deployment, along with model management, deployment, and monitoring via REST endpoints. So these are two database services that are supported with Exadata Cloud. You can run autonomous database, Exadata database service, or both on the same Exadata Cloud infrastructure. And both services can be deployed on Oracle Public Cloud or in customer data centers as well. The primary difference between the services is the management model. Autonomous database is fully managed with complete automation. Both the database and infrastructure are managed by Oracle, which eliminates administration to provide the best total cost of ownership. Exadata database service is a co-managed where customers manage the database and Oracle manages the infrastructure. Customers have root access to customized database environments and benefit from customer control automation to reduce administration. Now, with Oracle Autonomous Database, customers pay only for compute resources used. Auto scaling can be used by variable workloads to dynamically scale the compute resources up and down as required. Autonomous Database also has automatic optimizations for data warehousing, transaction processing, and JSON workloads. And with Exadata database service, customers pay for the compute resources they allocate and can scale those allocated resources as needed. It is also ideal for migrating any supported on-premises Oracle Database Enterprise Edition version to Exadata Cloud with no changes. So let's talk a little bit about Exadata. We know it's a premier platform for Oracle Database Services. It has extreme performance, scalability, and availability for data and AI workloads at a very low cost. Oracle Exadata is an enterprise data platform, right, that runs Oracle Database workloads of any scale and criticality with high performance, availability, and security. Exadata's scale-out design employs unique optimization that led to transaction processing, analytics, artificial intelligence, and mixed workloads run faster and more efficiently. Consolidating diverse Oracle database workloads on Exadata platforms in enterprise data centers, Oracle Cloud Infrastructure, and multi-cloud environments helps organizations increase operational efficiency, reduce the IT administration, and lower costs. So Oracle Database Exadata service delivers proven Oracle database capabilities, purpose-built, optimized Oracle Exadata infrastructure. It's built-in cloud automation, elastic scaling, security, and fast performance for all Oracle database workloads. Helps you simplify management and reduce cost. With Exadata database service, you have the choice and flexibility of running Oracle databases on uniquely optimized platforms in Oracle Cloud Infrastructure, multi-cloud environments at AWS, also on Azure and Google Cloud, and your own data center with Exadata Cloud at Customer. Exadata Database Service gives you the flexibility to address diverse business requirements with your choice of public clouds, whether it's Oracle, AWS, Microsoft Azure, or Google Cloud, or hybrid cloud deployments. It provides fully managed infrastructure and the option of license included or bring your own license model or consumption model. So this was just a quick summary of the enterprise capabilities you get with Exadata Cloud. You can innovate with OCI, Oracle Database Services running in AWS data centers with native low latency access to Oracle Autonomous Database and Oracle Exadata database service. You see all these capabilities, the complete Oracle database and Exadata capabilities in cloud, which are vector search, in-database machine learning, multi-tenant, in-memory DB, RAC, real application clusters, active data guard, partitioning, advanced compression, advanced security, label security, DB wall, advanced analytics, spatial and graph. You're able to offload AI search and SQL to storage, Rocky Fabric, um, XRMM data accelerator, smart flash cache, storage indexes, columnar flash cache, hybrid columnar compression, IO resource management, network resource management, in-memory fault tolerance, XF Fusion direct-to-wire protocol. So if you have all these capabilities that we bring into cloud, you can bring AI to your data and combine business data with LLMs using Oracle Database 23 AI's AI vector search and the Amazon SageMaker and Amazon Bedrock foundation models as well. You can migrate mission-critical Oracle database workloads to AWS and achieve the same high Oracle database performance that is available with OCI while gaining extreme availability and proven Oracle capabilities. And you can simplify management through native integration with AWS Console, APIs, monitoring, and operation. So you can purchase Oracle Database at AWS through AWS Marketplace, which we'll cover in the next few slides. So let's talk a little bit about benefits of Oracle Database at AWS, and I'll have Nathan talk about this section.
Awesome. Thanks, Divit. Great overview. And next slide, please. So let's talk about why this matters, or more importantly, how does it make your life better? And to consider that, let's talk about what were your options for running Oracle Database on AWS previously. You could self-manage your own Oracle database on Amazon EC2. You could run RDS for Oracle or RDS custom for Oracle. So what are the differentiators between Oracle Database at AWS compared to these? Well, customer managed databases are still a thing, but managing all aspects of your Oracle database or really any database product in the cloud denies you tons of advantages and time savings offered by automation. Study after study finds that managed services provide massive return on investment in terms of increased productivity, reduced unplanned downtime, improved security posture, and better performance. So they make fiscal sense, they reduce risk, they improve your operational stance, they improve your HA and DR readiness, and thus your business continuity, they increase agility, and more. So what else does Oracle Database at AWS get you? Well, that industry-leading performance and scalability of Oracle Exadata engineered systems, including the latest X11M hardware with modular scaling, Oracle Autonomous Database with self-monitoring and tuning on Exadata infrastructure, Oracle RAC for high availability and application continuity, horizontal scaling and load balancing, as well as rolling node maintenance, Oracle ASM for storage capacity and performance scaling, support for Oracle database features, including Oracle 23 AI with vector search and other built-in AI capabilities, Oracle Data Safe protection, features like Oracle Database Vault and SQL Firewall, also monthly security patching, and full support for migration methods, including both physical and logical, as well as supporting hybrid DR configurations. And with that hardware co-located in AWS data centers, the latency between your database and your applications is extremely low. You can manage your resources via the AWS console and APIs, and there's support for automation utilities like AWS CloudFormation and Terraform. And you have those simple purchasing options via the marketplace and tight integration with native AWS services, including zero ETL for analytics, AWS AI and ML services, and monitoring using Amazon CloudWatch. Next slide. So how do you get there? Well, standing up the Oracle database at AWS infrastructure and database is simple. You provision the Exadata dedicated infrastructure, You create your Exadata or autonomous DB VM cluster, and then you create your database. Migrating your existing on-premises Oracle Exadata databases to the cloud service is straightforward as well and can be done using the Oracle Zero Downtime Migration. Oracle Zero Downtime Migration, or ZDM, is a free tool that Oracle provides that automates a lot of the migration actions for you. ZDM supports Oracle Database as early as 11.204 through Database 21C and includes enterprise and standard editions. Now, depending on your source and target database configuration, you can leverage physical migration paths or logical migration. And migrations can then also be offline or online. So as one example, a physical online migration leverages Oracle Data Guard to duplicate the database from that source to the target in Oracle Database at AWS. One advantage of this path is that no significant temporary storage is required, whereas, say, a physical offline migration leverages some additional storage like Amazon FSx or Amazon EFS or S3 Storage Gateway to store backup files for restore into the target. You could also use an Amazon EC2-based NFS server or ACFS storage on the Exadata infrastructure to store those backups. On the other hand, logical migrations can be either offline or online and leverage, say, Oracle Data Pump, Export Import, or database links, and can leverage Oracle Golden Gate to keep the source and target in sync until cutover. Automated backups of your Oracle database at AWS databases is to Amazon S3, OCI Object Storage, or the Autonomous Recovery Service in OCI. And you can even use Oracle ZDM to migrate from Amazon RDS for Oracle to Oracle Database at AWS with automated data pump exports run on your RDS instance and uploaded to Amazon S3, then imported to your Oracle Database at AWS database. Next slide, please. So how else do you benefit from this partnership and service availability? Well, you can manage and monitor your Oracle Database infrastructure resources via the AWS console. And not only is the OCI hardware physically located in AWS data centers for that low latency, but AWS leverages the OCI APIs for resource management within the AWS environment. They even integrate notifications with Amazon CloudWatch alerts and Amazon SNS for notifications, or Amazon EventBridge for service actions. And as we mentioned, you can purchase this service offering through the AWS Marketplace, and that spend does qualify against AWS commitments and earns Oracle support rewards. So this service really gives you everything you use and love today in the Oracle database while running other pieces of your Oracle, your infrastructure and applications in AWS. And we're seeing this open up a lot of use cases for customers who just simply could not move their mission-critical Oracle RAC or Oracle Exadata database systems hosted on premises to the cloud previously. And now all of these services and capabilities are fully supported and available to customers running in non-Oracle public clouds like AWS. Next slide, please. Okay, so you can run your Oracle database and database applications natively on OCI hardware within AWS. With a low latency connection between Oracle database and other AWS services, you can expand to additional use cases. For example, you can leverage zero ETL integrations to reduce the amount of data movement you need to do and set up and manage in order to perform analytics, queries, and reporting on your operational data. Less ETL processes or ELT processes means less data pipeline management and faster access to fresh data, meaning more up-to-date analytics and reports. And that also means that you can build cloud applications, including scalable and platform agnostic container services like Kubernetes, or AWS managed offerings like EKS or ECS, including Fargate serverless, to move away from infrastructure management for those containerized application tiers. Containers make web applications more elastic and scalable, enabling you to take advantage of the greatest efficiency of the cloud while leveraging native AI capabilities in Oracle Database like vector search. And vector search really allows you to search on similarities within unstructured data like text and images, meaning you can return more relevant results to your users faster and with less work and resource consumption. Next slide, please. So let's just quickly look at some sample architectures of Oracle Database on AWS. Next slide. Thank you. So as we mentioned, the Oracle infrastructure, the Exadata infrastructure, is located inside of the AWS data center. This is really a key point to remember, this physical location versus logical location. The physical location is important for that latency in communication with other AWS services. The logical location is important for pairing with the OCI region with the AWS region for the lowest latency to OCI services like Autonomous Recovery Service or OCI Object Storage and the OCI control plane. So both the Exadata database dedicated infrastructure and the autonomous database are deployed in the customer's Amazon VPC and a subnet in an AWS region. That VPC is then paired with the ODB network for fast, private, secure communications with Oracle Database at AWS resources. The communication with the OCI control plane happens over the OCI managed network to the OCI region where your resources are logically deployed. And Amazon S3 can be used for automated database backups as well as Autonomous Recovery Service or OCI Object Storage. And this applies to both Exadata Database Service as well as Autonomous Database backups. Next slide, please. Now say that you have multiple application VPCs that need access to the Oracle database. You still have all aspects of the architecture on the previous slide, meaning you'll have a single VPC paired with your ODB network. You can then leverage AWS Transit Gateway to peer additional VPCs to that VPC that's paired with the ODB network in a hub and spoke model as is shown here. And this allows you to grant and control access to multiple application VPCs in a centralized, scalable way without managing individual VPC peering connections. Next slide, please. So say you have a deployment that spans multiple VPCs in a single AWS region, including resources deployed in multiple availability zones. Now, this might be a single application that's run in a multi-AZ configuration for high availability, or maybe it's multiple discrete applications. You may or may not host applications in the VPC that's paired with the ODB network. As you can see here in this example, that VPC is simply a transit VPC, and all peering and application connectivity is managed through the AWS Transit Gateway. In this case, we have a multi-AZ application configuration, and our application VPC spans AZs 2 and 3. We also have a firewall VPC with a firewall resource in AZ3, and the transit gateway may be configured to route application traffic to the database via the firewall VPC for security monitoring purposes, including intrusion detection and prevention services, session logging, or other monitoring, advanced filtering or session blocking, etc. And again, the connectivity to Oracle Database at AWS runs through that transit VPC, and all attachments are made to the transit gateway, which handles that traffic routing. Next slide, please. And then we expand this architectural concept to cross-region or even cross-account using multiple AWS transit gateways. In this case, each VPC in a given region or account will be attached to a transit gateway deployed in that account and region. And another transit gateway will be deployed in the region and account where the transit VPC exists and is paired with the ODB network and the Oracle database at AWS resources. Now, with those two transit gateways in place, you can create a peering connection between the two transit gateways to complete the network plumbing for the applications on the left side of the diagram to communicate with the Oracle database at AWS. And in such a way, you can deploy globally distributed applications and leverage the service on the back end. I'll hand it back to Divit for the next section.
Thank you, Nathan. And let's talk about user journey um, uh, for Oracle Database at AWS. Um, how we're gonna do purchasing, onboarding, provisioning, and management. So purchasing and onboarding tasks are one-time activities. So we're going to talk a little bit about that. Uh, let's talk about purchasing. When we go on AWS console, uh, here's the highlighted part, as you can see in the screenshot. Click on Oracle Database at AWS, and it'll get you a screen like this. And you have all these options over there. You can see pricing, benefits and features. You can scroll about it, all the stuff. And then uh, once you do that, you can request information as well if you need any information around purchasing. So once you're on the previous screen where you click on Oracle Database at AWS, you will see a link which says Get Started. You can request for a private offer yeah, or view your available private offers as well. When you click on private offers, you would see something like this, which will have the agreement and details around the contract. Once you get to that, you will see a screen like this, which is Oracle Database AWS info and what's been sold by Oracle America. And we will see options like what are the purchase options that you would have, uh, and we'll give you an overview, pricing, legal usage, support, and similar products that you can avail. So I'm just going through the purchasing mechanism that we have, what you can do on AWS Marketplace and how it looks like. Just giving you a feel of how the purchasing would look like. And then once you, on the right side, you see Get Started, you can click on the dashboard to view the dashboard as well. And check out the benefits and features. So,
Oh,
and let's talk about the onboarding piece. And I'll hand it over to Nathan now.
thanks, Divit. Next slide, please. Awesome. So to onboard to Oracle Database at AWS, you'll need both an OCI account and an AWS account in the region or regions where you want to deploy the Exadata database service or the autonomous database service on Exadata dedicated infrastructure. The onboarding consists of both gaining access to the marketplace private offer and accepting that offer, as well as granting appropriate permissions to manage linking your OCI account and your AWS account. Additional IAM permissions may be found at the top link, and these will provide you help in creating appropriate policies, roles, and groups to separate and effectively administer your resources. The account activation process requires an AWS and an OCI account where the OCI account will be linked to the AWS account. Your account will be linked in an OCI home region, which is where your original tenancy was created and where your IAM resources are defined. And if you want to take advantage of Oracle Database at AWS in multiple regions, you'll need to subscribe to the paired regions in your OCI tenancy before you can provision those resources in the AWS console. Now, these two links that are on this slide really provide step-by-step instructions on how to achieve all of this. So feel free to follow those links. Next slide, please. So let's talk about provisioning those resources. And one more slide advance. And here, if you don't mind, Divit, also start the video on this slide here. Great. So we got a short video of navigating the AWS console where we navigate to Oracle Database at AWS under the database category and begin provisioning our resources. Now remember, we'll provision the ODB network and the Exadata infrastructure and the VM clusters as the first steps before creating any databases. Now we can create service integrations at this stage. You'll see including S3 object storage and zero ETL services just by checking some boxes. Now, once we have our network defined, we can provision the Exadata infrastructure by selecting the Exadata generation and choosing the number of database services and storage servers to provision. And we can also adjust our maintenance window at this time to suit our business needs. We have the option to create Exadata VM clusters or autonomous database VM clusters on the same dedicated Exadata infrastructure. And we choose to create Exadata VM clusters here. And we specify our grid infrastructure version and Exadata system version, which servers to create VMs on, and then we configure the size of the VM cluster in terms of cores, memory, local storage, and ASM storage allocation. We specify our ODB peering connection and the Amazon VPC to peer with. And then once that infrastructure has finished instantiating, we can view Amazon CloudWatch metrics on those resources from the AWS console. And now, looks like the video, I got a little ahead of the video. So we're still provisioning these clusters. Okay, now we can see that our clusters are available. We click into those clusters, and now we can look at monitoring using CloudWatch graphs. So all of your standard CloudWatch metrics, you can see CPU utilization, IO metrics, including ASM, memory consumption as well. And now, noting our VM cluster name, we click over into the OCI console, and here we're going to see our VM cluster of the same name. And here we can create a database. So go ahead and create a database. Now we can adjust some of our pluggable database properties. We can set our automated backup destination. We can review and adjust our backup schedule, etc. And with that, we'll have created our Oracle database on our VM cluster. Next slide, please. And go ahead, one more. So let's talk about the roadmap for just a moment. After reaching limited preview in December of last year, Oracle Database at AWS went GA on July 8th. And as of GA, we have two AWS regions, US East 1, North Virginia, and US West 2, Oregon, each with two availability zones available. This is the Exadata Database Service and Oracle Autonomous Database, both on dedicated infrastructure available today. And as we move forward, of course, we'll be launching additional regions and functionality. Next slide, please. And speaking of those, so here we have those two initially US-based AWS regions highlighted in orange, along with a list of 20 additional regions planned that span the Americas, Europe, and Asia Pacific. Now, a lot of factors play into which regions we launch and in what order, and we encourage you to let us know which regions you're most interested in gaining access to Oracle Database at AWS to help us prioritize. In order to do that, work with your account team to identify those regions and features that you need to best serve your business needs. Next slide, please. And let's just do a quick recap of the features that are available at GA. So at a high level, as we mentioned, we've got the Exadata database service on dedicated infrastructure, as well as autonomous database on dedicated Exadata infrastructure. Oracle managed backups are available to Amazon S3, OCI object storage, and the autonomous recovery service in OCI. Amazon CloudWatch metrics and EventBridge integration help you monitor your resources and automate notifications and actions based on events. The zero downtime migration utility works for migrating databases to Oracle Database at AWS. Oracle Vault and Oracle Key Vault may be used for managing encryption keys for the service. And Oracle Data Safe includes database activity auditing and SQL Firewall. Major applications like Oracle EBS, JDE, and PeopleSoft are supported on Oracle Database at AWS. Networking today is a single ODB network peered to a single Amazon VPC. And from there, you can extend connectivity using AWS Transit Gateway or manage your entire global network using AWS Cloud WAN. And AWS supports Oracle Database at AWS in the AWS console, CLIs, SDKs, and APIs, as well as AWS CloudFormation and Terraform. And there's also a list of compliance certifications and attestations associated with Oracle Database at AWS. And in terms of availability, today that private offer is associated with one AWS account. And the AWS Cost Explorer shows product level usage while detailed billing is available in OCI. And next slide, and I'll hand it back to you.
Right, thank you. And this is for call to action. You can go to oracle.com/AWS for more details. Uh, and also, you can catch us on LinkedIn. Um, Search us on LinkedIn, Divit Gupta and Nathan Fuzi. And also feel free to send us any questions that you might have or any queries that you might have on our email addresses. My email address is david.gupta@oracle.com, and Nathan's email address is nathan.fuzi@oracle.com. And again, thank you for attending this webinar. Thank you all.
Thank you.